just want to think about this understanding of electrons or subatomic particles as waves or as particles. The wave nature of the electron. I remember doing a class when I was at school years ago about the wave nature of the electron and being completely baffled. In fact, it was that class that made me drop physics when I was at school, and I kind of wish I hadn't now. Because if I'd known then what I know now. Anyway, yeah, I mean, the key thing for me is that this wave particle thing is they're metaphors, aren't they? That's what they are. Effectively, they're metaphors, because the atom of which electrons and photons and you know, all the rest of that menagerie of particles are part of is, in a sense, unknowable in any concrete terms. I mean, people used to think that you could know what an electron was, and by know I mean intuitively know, visualize, if you like, have a concrete image of in your mind, which was a kind of one-to-one accurate representation of the thing that it was talking about. People used to think that. Early models of the atom, going back to Democritus I think, was of little tiny hard spheres with hooks attached, and these things would hook onto each other. And then, you know, when you get to something like Rutherford, doing that kind of classic model of the atom, which is on the front of biological soap powder boxes and those kind of things, the kind of solar system model of the atom with the nucleus at the centre and these electrons whizzing around in orderly fashion like little tiny hard planets. I mean, that was pretty much the last model which was visualizable for atomic structure. You know, I mean, you look at that and it is again intuitive. It appeals because we know what, I don't know, putting a ball on the end of a rope is and doing this, we kind of know what that's like, and we've seen lots and lots of pictures of planetary motion, and we look in the sky at night and we see all this stuff happening, and we have a good sense of what's going on, or we think we have a good sense of what's going on there. That, you know, the Rutherford model of the atom looks like that, but we know it's not like that, you know, and lots of studies in atomic physics since then have required that model be made more complex. But as soon as it gets more complex, it leaves the realm of the intuitive and stops being visualizable. Which isn't to say that there aren't drawings and images of atoms, but they're not one-to-one representations anymore. You know, you'll get some, at least I've seen some images of atoms which try to bring out the nature of the electron shells. You know, so you'll get concentric spheres around an image of a nucleus, with these spheres representing the different electron shells that, as I say, electrons can move between, and that's a partial representation in yeah, a partial representation of what's going on. But you know, but you need other ones. You know, others I've seen images of kind of probability clouds, different shaped probability clouds. Some shaped like dumbbells, and some shaped like planet Saturn, and shaped in different ways. You know, to represent a different aspect of what an atom might be thought of as being. But you can't make a single one. All of these different images just represent different aspects of it, and the idea of a wave as well. You know, Pyro and Gary have been talking recently about the double slit experiment, and the double slit experiment is about this wave particle duality in a sense. It does demonstrate that at times the photons in that case behave as if they were waves, and other times behave as if they were electrons, or appear to, depending on how you measure them or how you interact with them. And when I say behave as if they were, what I mean by that is appeal to an intuition which understands them as if they were. They're not really either switching between, I guess they're not switching between being some kind of wavy thing and being some kind of particulate thing. They're just our interpretation, our attempt to understand, our attempt to intuitively grasp what's going on there. In some circumstances leads us towards an understanding which is a bit like understanding how waves work, and at other times it's a bit like understanding how lumps of stuff work. But as I say, there's no single model, because our intuition won't stretch that far. We haven't, our intuition, at least this is an idea I'm kicking around, I think our intuition is the intuition of appropriate to our embodiment, and our embodiment is medium-sized, medium speed lumps of stuff, or waves in things, like waves in water, waves in some kind of medium. Our intuition is not designed for those other things. Phoebe, guy, come on! So yeah, come on. Sorry, just taking my dogs out of the way so they don't get into a fight. Yeah, so at some point we just have to leave those behind, those images behind, and recognise that the not only is the physical image on the page, these representations in physics textbooks about what an atom is, not only are they not complete, they bear the same relationship to an actual atom as a graph of the economy does to the real economy. The real economy is not a series of coloured bars out there in the world that you can go and touch, but it's our representation of that. In a similar way, a picture of an atom is not an accurate representation of a thing you can go out there in the world and find. It's not a photograph. It's a kind of graph. And yeah, and I would guess that we've got similar kind of graphs going on in our mind when we're trying to understand things. Those drawings that work, those images work. Those images of atoms as little solar systems or as clouds of probability. Those work because they appeal to an intuition that we already have. We know what clouds are and we know what solar systems are intuitively. And similarly, it's not just that they work on the page, they work in our brains, they work in our minds, I think. And it doesn't do to attach ourselves too closely to them, because these are always going to be approximations. They're two-dimensional they're like trying to do a two-dimensional representation of a three-dimensional object. It's always going to be some loss in that. And similarly, trying to do a cognitive representation of this kind of physical experience, entity, object, world, universe, there's going to be a lot of loss in that, and a lot of approximation, and a lot of artifacts thrown up by that process of approximation, it seems to me.